Okay, so this problem right here says complete the sentences below based on the graph of the function. As x increases, what happens to y? Well, look right here. When x is 0, y is 1. When x is 2, y is 2. So when x got bigger, y also got bigger. So when x increases, y also increases. The rate of change of y as a function of x is increasing. See, the rate of change is going which way? Up. Therefore, the function is also increasing. Let's read the third one. For all values of x, the function value y is what? 0. Yeah, my entire graph is above the x-axis. Here's the x-axis. My entire graph is above it. So my y is going to be greater than 0. Okay, that's what that one should be. If the entire graph were below the x-axis, then I would have put a what here? Less than. Okay, let's read the next one. The y-intercept of the graph is y equals what?
1.
Yep, y equals 1 is the y-intercept. And so your y-intercept is right here at 1, right? So we would say the y-intercept of the graph is the function value y equals 1. Now look at this part. When x equals 6, the function value y equals what? So when x is 6, y is all the way up here at 7. Okay? So here it says complete the following sentences based on the graph of the function. This is the graph of A, and they want to know, is it linear or nonlinear? Nonlinear. It's curved. It's not a straight line, so this would be nonlinear. The y-intercept of the graph is the function value y equals what? 1. It crosses the y-axis. See right here, it tells you it's the y-axis. It crosses the y-axis at 1, so right there you'd put 1. The smallest positive x-intercept of the graph is. Now, let's circle all the x-intercepts. There's an x-intercept, there's an x-intercept, there's an x-intercept, and there is an x-intercept. Now let's list all our x-intercepts at negative 2 pi, at negative 1 pi, at pi, and at 2 pi. Now, here, these are all my x-intercepts. Remember, an x-intercept is where it crosses the x-axis. The smallest positive x-intercept. Well, these are both negative, so they don't count, do they? Which one of those is the smaller of the two? Pi. So right here in the box, you would put the word pi, and that'll give you the symbol pi in Khan Academy. The greatest value of y is, y equals what? Yeah, where does the maximum happen? It happens right here. That's the maximum of the whole graph, and that's at 1. So it's 1. And it says, and it occurs when x equals what? 0. Good. So when x is 0, y is up here at what? 1. So when x equals 0, y is at its max. Now it says for x between pi and 2 pi, the function value is y blank 0. So it's saying between pi, here's pi, and 2 pi, is the graph below the x-axis, above it, or on it? Below. So from pi to 2 pi, the graph is below the x-axis, right? So what symbol would go right here? Less than. So y is less than 0. It says the graph below describes the cycles of the moon as observed from Earth during the first 60 days of the year. The percentage of the moon which we see varies as a function of time. A full moon is 100%. So when the moon is full, that equals 100%. Okay? And a new moon corresponds to 0%. So a new moon is 0%. Okay? And so look at this graph. The y-axis here is your percentage, and the x-axis here is the number of days, right? So right up here, what percentage is this peak? 100%, right? And so 100% means it's a what moon? Full. And then you can see the visibility of it goes down, and then all the way down here, it's back at what? 0, right? It's at 0% visibility, and that's after how many days? 24 days, right? Okay, so now let's read the question. The first new moon of the year was on what day? Now this isn't a new moon, is it? It's a what? Full. So that's not the answer. The new moon happens when it equals 0, and so that's after how many days?
24 days.
24 days. Now it says here, the second new moon of the year was on what day? So there's another new moon right here after how many days? 51 days. Good. Now it says, therefore, the period between the two new moons is how many days? Yeah, you can just do 51 minus 24, and it gives you what? 27 days.